Okay, today we'll be starting in section 4.6. We have done 2 out of the 6 graphs, right? Because we have 6 trig functions, sine, cosine. Today we're going to focus on cosecant and secant. And then the second day we'll focus on tangent and cotangent. All right, so yeah, sine and cosine, we took almost 3 days to get through it. So we can't do that for all these now. What we're going to do is take this as an opportunity to work on technology and working on putting them into either your graphing calculator or the Desmos online graphing calculator, okay? So the notes will mainly focus on the graphing calculator if you have one. If you don't, I'll follow this up with a screencast, separate video. Should be short, just showing you how to work through these on the Desmos, which is a very handy online graphing calculator. Okay, so here we go. Let's start with cosecant here. Cosecant, as we remember from before, is the reciprocal of sine. So you probably want to handwrite this in here to remind you. Okay, cosecant is the reciprocal of sine. So when we actually go to our calculators, this is how we have to punch it in because there is no CSC button. So we do 1 over sine of whatever x is. All right, so I'm going to give you a little intro to this cosecant graph. This very lightly drawn graph in here is actually the sine function. I want you to label it as sine of x. And that should look familiar, right? We know the sine starts at the origin. At the next tick mark, it goes right up to its max. This isn't labeled, but you probably should do that once you put a tick mark there, pi over 2. And then we know the pattern for sine comes down back to the midline. Next tick mark, it goes down to the minimum. And then 2 pi. So this is a y value of 1, and this is a y value of -1 here for the parent function. Okay, so this one naturally is going to be -pi, and then this is going to be -2 pi way over here. Okay, so we're starting with the sine because now we can use that to our advantage to get some points for cosecant. So for example, let's take a real easy one. Sine of 30 degrees. If we had to draw a reference angle and go through all that, it's 1/2. Just trust me on that. Sine of 30 is always 1/2, okay? And we see that on the graph here. Pi over 2 is 90, so 30 is about right here. So that 1/2 matches up. It's on our graph, okay? So what's the reciprocal of that? Well, cosecant of 30 degrees then naturally will be 2 over 1, or just 2. So at 30 degrees, or about pi over 6, I'd go up to around 2, and that should be on the graph of cosecant. Okay. All right, to help fit some other points, let's use some of these key points we use for sine. So for example, you don't have to write this part down, just kind of watch. I'm just demoing this. We know sine of, let's jump to pi. Sine of pi, by definition, is y over r. So I'd have to use this point to get that. I'd rotate all the way over here to use this coordinate. So it'd be 0 over 1. That's what I get for sine. So what would cosecant of pi be? Well, if I flip that over, I'd do 1 over 0 and get undefined. Okay? So at pi, we get a value for sine of 0. It's already there. But if it's undefined for cosecant, there's actually an asymptote on the graph here. Go ahead and draw that asymptote through at pi. Okay, I'm just getting some key points to get this going, and we can fit the cosecant. All right, what about pi over 2? Well, sine of pi over 2, I'll just write it here this time. Sine of pi over 2, or 90 degrees, I'd be using this coordinate, and it'd be this y value, so 1 over 1. So sine of pi over 2 is 1. So cosecant of pi over 2, once I take the reciprocal of that, I still get 1. So cosecant is going to kind of share this coordinate with sine. Okay, and then the same thing happened with at 0. Sine of 0 is 0, and then if I flip that over, I get undefined again. So there's kind of another asymptote right here. All right, so here's kind of what the cosecant graph looks like. It kind of looks like a horseshoe. It goes through that point, it comes down and touches that same spot as sine does, and then it goes back through and up and does this, runs along these vertical asymptotes. Okay? All right, I'm not going to keep breaking down every section like that. I just wanted to give you a little intro to why it looks the way it looks, I just want to throw it at you, and you're like, what the heck? What? That's a weird looking graph. Well, there's a reason for it, right? So if I take these reciprocals, this is just the outcome. All right, it does the same thing down here. It's going to share this point in common. There's actually another undefined spot at 2 pi. And then the graph of cosecant does this. It comes up, it touches that spot in common, and works right along these vertical asymptotes like so. Okay, I'll show you a computerized version of this in just a second. All right, so here's what it looks like. Okay, so like I said, I broke down a few of those points for you. Now it doesn't have sine on here now. We were using that as an introductory tool, but they kind of just do these little U-shape or upside down U-shape curves. Okay. All right, and you can see after it goes from 0 to 2 pi, it's just going to start repeating itself. That's why I didn't continue on. But we'll see that same cycle again, over and over again, okay, in the positive and negative direction. Secant kind of does the same thing. It takes that cosine graph and it does the same thing, flips those over, and it just has a different starting point. That's all. All right, so that's what they look like here. So the secant graph, it's kind of do the same thing. This is also typed in as 1 over cosine of x. Okay, and it's going to look like this. Its asymptotes just occur at a different spot. So there's an asymptote at pi over 2. And then over here at 3 pi over 2. And it just kind of continues that pattern. All right, I'm actually going to go back to negative pi over 2 over here as well to get another asymptote, just so that I can compute or complete that U-shaped curve. All right, so secant, excuse me, run it along these vertical asymptotes, touch that shared coordinates, and take it up like that. Okay, secant does the same thing down here, shares this coordinate. Okay. All right, now technically from 0 to 2 pi, that's really kind of our cycle right there. But if you wanted to go back to one asymptote to kind of complete that at times, you might want to, especially if the directions say complete 2 full periods. All right, so the period for cosecant is 2 pi. Same as its reciprocal function. So it's the same period as sine that we're accustomed to. Okay. For secant, same thing. It's 2 pi, same as cosine. Okay. All right. The asymptotes have a little bit of a pattern as well. For cosecant, they occur on these multiples of pi, 2 pi. If we kept extending, we see another one at 3 pi, 4 pi. Okay, so these occur at multiples of pi. Okay, so for example, if you needed it, x equals 0 pi, right? 1 pi, 2 pi, and so on. All right, and secant, it just moved over a little bit. We call these the odd multiples, like 1 pi over 2, 3 pi over 2. The next one's going to be at 5 pi over 2, 7 pi over 2. So these occur at odd multiples of pi over 2. Okay, and don't worry so much about memorizing that. It's just more of just seeing the pattern right now. Our calculators are going to help us pinpoint that pretty easily. Okay. I'm going to use this space to kind of give you the success criteria in the graphing calculator steps. All right. So the steps below would be a little more suitable if we're going to do everything by hand. But like I said, I want to use this section as a chance to show you some tech steps and calculator steps. That's a skill you guys should have heading into calculus if you take it. Okay. All right. Okay, so let's just replace all this. So step 1 says to find the period and scale, just like the tick marks that we've been doing, and set up the graph on paper. And then, of course, if they ask, the phase shifts and the vertical shifts are going to be the same as section 4.5. The C over B, the D value is the vertical shift. All that transfers to this section, so thankfully you don't have to relearn all that. Okay, so then on step 2, you know what, I'm just going to give you a chance at home here to just pause the video, write this down, and then I'll kind of walk you through it as we start these examples. Okay. Okay, so also make note, you want to put your calculator in radians mode when you graph these. All right, so here we go. I'm going to take you right through these steps. Notice we didn't say anything about amplitude here. Amplitude is something that only describes the height for sine and cosine from the midline. This doesn't have a determined height, right? It goes indefinitely to positive and negative infinity. So we are not going to use the phrases amplitude for this section. Here we go. Let me take you through these steps. Let's go ahead and graph 2 periods again. That's what your assignments will ask for in your next assessment. All right, so these steps allow us to do most of the work on paper, and then the calculator part's only going to be about 1/4 of the work, just kind of finishing everything. So we're going to find the period. Step 1 is what it says. Just like before, we're going to do the same thing. 2 pi over b. My b value right now is 2. So 2 pi divided by 2, and we get pi. Okay, now to set up our tick marks or scale marks, we like to take quarter periods. Still, all that stuff is going to be transferred as well. So again, I'll just write down what we do. Our period divided by 4. So our period was pi over 4. Okay. So no calculator needed for this. We just start adding pi over 4. All right, remember the second one, or 2 pi over 4, reduces to pi over 2. Now I'm at my third pi over 4, which doesn't reduce, and then the fourth pi over 4 reduces to pi. If we already have that down from before, now track backwards like we've done before too. I'm just going to do every other. Negative pi over 2 and negative pi. Okay, there are no phase shifts or vertical shifts going on because C is 0, D is 0. All right, so now let's set up our window on paper, same as in our calculator. All right, so let's go ahead and start getting this set up on our calculator now. Okay, so we're on to step 2. All right, we're setting up our window exactly as it is on paper. So here's kind of my window, right? You don't have to draw this in here unless you want to. I'm kind of have a light little sketch of the window we're trying to create. All right, so my graphing calculator, I want my X min to be over here. If you want to label it like that, go ahead. This is my X minimum, and over here is going to be my X axis maximum. That's how these windows are set up. So go to window, X min, mine's 0 right now. I'm going to put in negative pi. Okay, and it changes the decimal form for me. X max, positive pi. My scale is the tick marks or scale marks that I just found. I want that to be pi over 4. So pi divided by 4. Okay, now Y min and Y max, you kind of just play with this number. It does kind of stretch the height a little bit. So let's just maybe start with -6 to 6, but you can kind of play with these depending on your experience with them, and you'll get better at knowing how high to go. But let's just start here, okay? Adjust that as needed. And we probably just want a Y scale of 1, not 0.1 like I have right now. All right, we also got to make sure our mode is in radians. So I'm going to go to mode. I'm going to highlight the radians. And of course, we need to plug in our function in our Y equals. Okay, so our Y equals needs to look like this. All right, I'm going to put it on paper here too. Y equals -3, and then in parentheses, we're going to do 1 over sine of 2x. You got to remember that reciprocal relationship. Okay, so that's what we're going to do for this one. -3, parentheses, 1 divided by sine of 2x. Okay, now complete the graph on the next video.